Welcome again, wonderful Wildcats, to Friday, November 3rd, Radical Transformations, and that's going to be on page 29. So if you would, update your table of contents. All right, now your table of contents are updated. Let's take a look at our notes. All right, these should look familiar. We've already done transformation notes, and it's really the same thing, except for instead of parentheses, we have the radical, or the square root, okay? So go ahead and write down the f of x equals part of the notes. All right, so now let's just break down each part. If the negative in front of the a, that reflects over the x-axis. When a is greater than 1, it's a vertical stretch. When a is greater than 0 but less than 1, it's a vertical compression. When a negative is inside of the radical, it reflects over the y-axis. And when b is greater than 0 but less than 1, it's a horizontal stretch. When b is greater than 1, it's a horizontal compression. And when it's plus 8, it translates left. If it's minus 8, it translates right. If it's plus k, it translates up. If it's minus k, it translates down. All right, so finish up your notes. All right, now let's take a look at our examples. All right, it says graph the radical function and state the transformation, then state the domain and range. All right, so here we have a radical exponent, or rational exponent, but we can write it as a radical, or also known as the square root. Okay, x to the 1/2 is the same as the square root of x to the first power. Now, we usually don't write that. We just write it as the square root of x. We don't usually write the 1 or the 2, but technically that's where the 2 and the 1 go when it's written that way. All right, so now we're going to graph. Now, when you see an x and y, we're graphing with actual points. And we're going to do this because once we know the points of the parent function, the parent square root function, then we can use those points as our directions. So let's start with x is 0. So the square root of 0 equals 0. The square root of 1 equals 1. Now we're not going to do 2 or 3. We're going to do 4 because we know the square root of 4 is 2. And we're going to use 9 because the square root of 9 equals 3. All right, so now let's go ahead and graph. So 0, 0, 1, 1, 4, 1, 2, 3, 4, 2. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3. All right, now domain is bracket 0 to infinity, and the range is bracket 0 to infinity. Now, this is the same as the square root. I just wanted you to know that x to the 1/2 is the same as the square root of x. Now, even though this says example 2, we're not going to do example 2 next, because what I've done is I've divided these examples into square roots on the left, cube roots on the right. So we're going to move on to example 3. All right, example 3. Okay, so we're going to graph by direction. All right, so we know the directions, but before we move the direction, we need to move the vertex. And we know the vertex goes down 4. So 1, 2, 3, 4. Okay, now that's our new HK. And we're going to use, these were points, but they're also now our directions for square root. So 1, 1, 4, 2, and 9, 3. But we're multiplying the square root by 2, so we have to multiply all the y's by 2. So that's 2, 4, 6. So from here we go to the right 1 up 2, to the right 4, 1, 2, 3, 4, up 1, 2, 3, 4, and to the right 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, up 1, 2, 3, 4, 5, 6. All right, so our domain is bracket 0 to infinity, and our range is bracket -4 to infinity. Our transformations are a vertical stretch of 2 and down 4 units. All right, so go ahead and finish up example 3. All right, now let's look at example 5. All right, example 5. All right, so we're going to graph by directions, but before we do that, we need to move the vertex. So this means we move it right 2, up 3. 1, 2, 3. Now we're going to graph by direction. All right, so we know we just moved our HK, so now we know we're using the directions 1, 1, 4, 2, 9, 3. But because of the negative in front, we multiply all of those by -1. So that's -1, -2, -3. So now we go to the right 1, down 1. To the right 4, 1, 2, 3, 4, down 2. And to the right 9. So 5, 6, 7, 8, 9, down 1, 2, 3. All right, so our domain is bracket 2 to infinity. And our range is bracket, not bracket, because it's reflected. We know we're going from -infinity to bracket 3. All right, our transformations are reflect x-axis. Oh, what was that? That was a bell. Silly bells. All right, and then we have right 2 units. And then up 3 units. All right, so that's the square root portion. Now we're going to move on to example 2 where we talk about the cube root. All right, so x to the 1/3 is a rational exponent, but can be written as a radical. So that's the cube root of x to the first power, which we don't need to put the 1, so we can just write it as a cube root of x. Now we're going to do example 2 so we can learn the directions from the parent function. So we have to find the points from the parent function, which will give us our directions. All right, so here we're going to do -8, and the cube root of -8 is -2. We're going to do -1. The cube root of -1 is -1. 0, the cube root of 0 is 0. 1, the cube root of 1 is 1, and 8. Cube root of 1 is 2. And they were picked because we know the cube root of 8, 1, and 0. All right, so we graph that. We go left 1, 2, 3, 4, 5, 6, 7, 8, down 2. Left 1, down 1, 0, 0, 1, 1, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2. All right, we know our domain is from -infinity to +infinity, and our range is from -infinity to +infinity. And x to the 1/3 power is the same as the cube root function. All right, so we did that. So now we know the directions are, these points can be used as a direction, and 0, 0 is our vertex, or HK. All right, So, example 4. So we're going to graph by direction. All right, so we know first we move the vertex up. Plus 3 moves, we move left 3. So 1, 2, 3. And then we graph by direction. So -8, -2, -1, -1, HK, 1, 1, 8, 2. So we go left 1, 2, 3, 4, 5, 6, 7, 8, 2. So let me count again. 1, 2, 3, 4, 5, 6, 7, 8, 2. Left one. Oh, wait a second. That's a -2. So we go left 8 down 2. Then left 1 down 1. To the right 1 up 1. And then 1, 2, 3, 4, 5, 6, 7, 8 up 2. All right, and again, our domain is from -infinity to +infinity, and range is -infinity to +infinity. Transformation, we only have one. It is to the left 3 units. All right, so finish up example 4. And let's look at example 6. All right, so we move the vertex, it looks like right 3, and then up 1. And then we're going to graph by direction. So -8, -2, -1, -1, HK, 1, 1, 8, 2. All right, now we see the 1/2, so we know we need to multiply the y values by 1/2. So -2 times 1/2 is -1. -1 times -1/2 is -1/2. And actually, since we're graphing, probably 0.5, -0.5. HK, 0.5, and 1. So we go left 1, 2, 3, 4, 5, 6, 7, 8, down 1. Left 1 down 1/2. To the right 1 up 1/2. And to the right 1, 2, 3, 4, 5, 6, 7, 8 up 1. Okay, we know our domain is -infinity to +infinity, and our range is -infinity to +infinity. And so our transformations. Let's see, vertical compression of 1/2, right 3, and then up 1. All right, so at this point, you have 2 paths. Path 1 is you can circle the examples that you want me to go over again in class, and we can work with that. Or option 2, start working on the assignment before class. All right, so with that, I want to let you all know that Altuve and Carrera were awesome with 2 home runs. But Jackie Robinson is the all-time greatest baseball player of all time. In fact, so great, they retired the number 42 from all of Major League Baseball. So whoever you're going for tonight, enjoy the game and have a wonderful Wildcat day.